Hi, Engineering Space Cadet. So today we're going to go over data types and data structures in Python. This is going to be a basic overview of the primary data structures and data types inside of Python. So this is going to be a more expanded out version of the intro video where I briefly talked about data types and data structures without inherently going too deep into them. And as we're going through this program, there's going to be a lot more implementations that we're going to use for data types and data structures, different ways of handling these different data structures and data types, and implementing them for our code. So maybe in the future, you're going to start getting used to doing just basic coding questions. And you're running into problems because you're like, okay, I learned some basic concepts from Python. However, I can't solve these coding problems. It's asking me for something that I'm not exactly sure about. Now, this is not going to be an algorithms video. That will be another video, and we may do that at another time. For now, we're just going to go over the basic, the very, very, very basic data structures that are commonly used, and we'll expand out to more intermediate data structures and algorithms in another video. Okay, so let's get started. On the spaceship, now I'm a space cadet. Big white legend in my habitat. So when I say a data type or a data structure, what do I mean by that? So when it comes to a data type, it is just a very abstract view of some kind of data. So every single bit of data that we're using has some type, right? So that type may be a class, it may be a string, it may be an integer value, it may be a float point value. It could be a list or a dictionary. These are all different data types. They're very abstract. They're not in implementations of these data structures. It's more of just a way of labeling to know what it is and how to use it. So if we had an integer value and that integer value is an 8-bit integer value, that is just saying that that integer value has 8 bits. So we can handle 8 bits within that integer, but in Python, we really don't have to worry about that too much. But it's helpful to know that a data type is a very abstract view of the way that we're handling the data, and a data structure is the exact implementation of that data type. But it can also be a collection of different data types. So you can have something like a list in Python that has more than one data type inside of it. So we could have an integer value with a string value, with a dictionary or a nested list, and we could do a bunch of different things like that. So for now, we're going to go in depth into some of our common data structures and understand how they work, why they work, and you'll see that a lot of them are connected in very interesting ways, where they're very similar, but different, but they're just different ways of handling the same kind of data. Okay, so we're gonna get started with one of the common, most useful things in Python, but you probably don't think about it as much as you probably should. So we're gonna talk about a string. So I can just call this string, let's go with the new string, right? New underscore string, and we're going to equal out this new underscore string to some kind of string value. And since one of the first things you learn as a programmer is hello world, I'm just going to keep it this way. But actually, I'm going to add 2 spaces in here because I think this is important. So when you're looking at hello world, you know that it is a string of characters. So you see HELLO space, comma, space, world, which is WORLD, and each of these characters has a position. So if you're asking what I mean by position, a position is just the location of that string in a numerical format. So if I was looking at H could be in position 0 because that's where we start off in Python. Most things start at 0. They don't start at 1, like some other languages. Most common languages that you run into tend to start at 1 or start at 0. So position 0 for hello is going, or for the new string is going to be H. And that's the beginning part of this hello. And then we have E in position 1, position 2 is L, position 3 is so on and so forth. So I can kind of label this out where I have this string or this comment which has hello, H, E, L, L, O, space, comma, space, and then W, O, R, L, and D. So right here, we're going to label these with their position values. So we're going to have position 0 is H, position E is 1, 2, 3, 4, and then the space is actually another position value. This comma is a position value, which is 6. So we're going to put that there. And this other space is also another position value. Then 8, then 9, then 10, and 11, and then 12. Now, sometimes when it comes to this, you're going to see these spaces, and you're going to be like, I can't believe these are actually position values. But if you think about it in a whole, each of these are located for a specific position, right? So this isn't immediately followed by this comma. There is space there, so that space takes up a position, as well as this one does. So if we print this, is going to be the length of this hello world, and the length of this is going to be 0 through 12, which is actually 13, because this is essentially like a 1, and this is all the way up to 13. But since we include it, and it's inclusive, is a length of 13. It should be. So if we print out the length of this string, or this new string, it should be like 12 or 13 or something like that. But essentially, we should be able to, yeah, so 12 or 13. And this is probably like at this in value where there's like nothing there. But essentially, each of those will have some position, right? And we can print that out. So what we're going to do is we're going to create a for loop. So for I in range of, yeah, I was right the first time. This is 13. So for I in range of the length of this new string, I'm going to print out every value and its corresponding position. So we're going to have a print statement here, and I'm going to have an f string, and I'm going to say that this position value is I, and the value at this position, so value at position I is, and we're just going to put in here our new string value, and we're going to add these brackets and this I. So these brackets are basically saying, tell me what is at this position in this new string. So we'll print out the position. The value at position I is this value, and we should see that printout here. And you should see that at position 0, the value at position 0 is H, so on and so forth, as you see. So the length of this is 13, and the number of position values here is 13, going from 0 to 12. So you're like, okay, so how does that help me? Well, you can think of a string in a bunch of different ways. So we can use something called slicing in Python to just print out particular parts of the string. So let's go for, we'll print out this new string. And for this new string, we're going to start at position 0, and we're going to go to about position 5. And we're going to run this. And you can see that when I'm printing out from position 0 to position 5, based on this new string, which I labeled out here, you can see from position 0 to position 5, I'm printing out just this hello. Now, let's say, for example, I just want to print out world, right? So I'll print out this new string, and I'll slice it, and I'll start at position 8 and end at position 12. So we'll start at position 8 and we'll end at position 12. Oh, well, maybe we should end at position 13, actually. So you can see that from here to here, we can print out hello and world, and we're slicing these values in a way that we can just use them. This can be very useful because in Python, we have something that is essentially negative indexing. So instead of explicitly saying that position 13, I could just print the value of, let's see, new string, and I can negatively index to -1, which is going to be the position of D, as you can see. So Python allows you to do that. So there's expanded out functions that you could do with that, where you could print out this entire thing reversed. So let's just say, for example, if I had a function and I define this function, call it reverse string, and I pass in a string value. So we're going to call this string value. We're going to label this with its type, and then we're going to return another string value, but this is going to be a reverse string value. So this right here returns a reversed first string. Okay, so essentially there is a long way to do this, which is basically we take in this string and we have we're going to have a temp string, and we're going to equal that to string dot split. And this is a method that happens on a string method, which allows us to split up the values. But instead of this, I'm just going to turn this to a list. So we're going to call this list string, which we're going to go over lists pretty soon. And I'm going to turn this string into a list. And what I can do here is for, so we're going to set a temp value, which is going to be equal to 0, and for I in range of the length of the string, essentially, let's just divide this by 2. I can take this list string value at index 0, and we're going to set this temp value equal to that list string at index I. And then what we can do here is we can take this listed string at index I. We can set this equal to the listed string, and we're going to go from the listed string all the way to the end of the list, which is going to be the length of the string value, and we're going to subtract I from it, and then we're also going to subtract 1, and then we're going to set this list string at length of the string value minus I. and there's subtract 1. And we're set that equal to the temp value. And then we're going to return this join value for this listed string. And essentially what should happen here when I call in a string value, so if I call in, I print out the reverse string with the value of new string, I believe this should just reverse it. And as you see right here, this gives us a hello world reversed. And essentially what we're doing is we're taking the length of the string based on its position values, and we were swapping from position 0 and position 12. We're swapping there, then swapping from 11 and 1, swapping 2 and 10, 3 and 9, so on and so forth. And that's essentially what we can do with this indexing idea. However, in Python, there's an easier way to actually do this. So we can print new string and just create this brackets and have this here, -1. And this essentially is going to give us the same thing, right? It gives us the same thing. It doesn't really matter. It's just knowing that this slicing method happens with strings is very, very helpful. It's a way that we can kind of process strings in different ways. We can split up strings in any way that we want to. We can increment and decrement just depending on the way that we want to look at the string. But this string is essentially going to act like a list, which we have not gone over. So that's probably going to be a little bit more confusing until I explain what a list is and then go into the details of how a list works. So you see this brackets, and these brackets that you see are essentially ways that you define a list in Python. Now, if I didn't go over lists previously, a list is essentially a list of data types, or an array list of data types. But although in Python we don't use the word array as much, we use list. There is a specific connotation for an array versus a list, or an array list. But here we're just going to focus on the list in Python. So essentially we can have a bunch of different data types underneath this new type of data structure called a list. And because we can put a bunch of different data types under this list, it's not as specific as something of just a specific data type. So a data type could be an integer value, and a list can contain a bunch of integer values, or it can contain integer values and float point numbers or strings and such and so forth and so on. So we're going to create something, and we're going to call this one new list. And we're going to create a list by creating these brackets, and we're going to pass in a bunch of values. So we can pass in 0, 1, 2, 3. Actually, we're gonna do like regular numbers, except I just mean we're starting at 1 instead of 0. 2, 3, 4, 5, 6, 7, 8, and 9. Okay. So this should be a length of about 10. So it's, or maybe 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, a length of 9. And if I was to look at this at the index values as we did with strings, it should be from index 0 to index 8. So if we print out here, which we can use our length of our len of our new list, and it should tell us that it's a length of 9, right? And because it's a length of 9, we can still index these values from 0 to 8. So if I was to print out the values of, let's see, print out, essentially this new list is value, new list at index 8. There we go. It's just going to give us 9, right? And if I do the same thing where I print out this new list at index 0, it's essentially going to look just like what we did with our strings. So you're like, oh, well, why is that useful? Well, a string is its own data type. It's specifically for a string type. However, I don't need essentially a string, or I don't need an integer type in this list. I did this for simplification, but also at the same time, I could take this value, and instead of having 9, I can have hello. And we can print this out, right? And I can print out hello in this position, and Python handles it just fine, right? I could also look at position 5, and I could add in another list here. And this list value at 5 could be 1, 2, 3, and 4. And I can take this value and I can print out position 4, or 0, 1, 2, 3, 4. Yep. At position 4, it's a new list. And essentially, it's just going to give me a list. And I know it's brain breaking. But essentially, we're just taking a bunch of different data types, and we can just smack it inside this new list. It can be very useful depending on what we're doing. A lot of times when you're handling data, it may come in a list form, and you may want to handle that data. So let's say, for example, we take this new list and we use a for loop on it. So we could print, so for I, let's just go with a different thing. For number, or num, and length of the new list, or range of the length of the new list. Range the length of the new list. Essentially, we can just print out every value inside of this new list. So we can print out this new list value, new list, and we can print out number from this new list. Now, essentially, I'm going to change this to element for, or ele for element, because that's essentially what we call these values. They're elements inside of this list. And I'm just going to print those out one by one. And you can see, essentially, I printed out 1, 2, 3, 4, this list, 6, 7, 8, and then hello. These are all values that are all valid within Python. So a list can be very, very useful. And a special trait of lists inside of Python is, instead of having this range of length of new list, I can do a for loop on it. So for value in our new list, I can just print out that value, which is a more direct way of accessing elements inside of a list. And you can see that it works the same way. So there's a lot of shortcuts and ease of use with lists, and the way that we can handle those lists, the way that we can nest those lists, use other lists and other lists, and the methods that come for those lists are all things that we can do in Python. So there's a bunch of different methods that happen for different data structures. Essentially, we have a string, or a list of strings, and we can handle that as a list. And we have these lists, which we can also handle in the same way that we did with our strings. You can see that there's a lot of useful information that you can glean from using data structures for strings and lists. Another data structure we're going to go over is a dictionary. Now, let's say, for example, I guess the simplest way to look at it is, think about if you had a book, right? You have a book and it's full of pages, and in that book of pages, you're looking for something very specific. You go to your table of contents and you say, hey, I need to find, let's say, for example, we have a Python book, and I need to find a value inside of that Python book, and I see what chapter it's related to, and the content is strings or something. Now you go to the table of contents, look up your table of contents, look for the chapter that says strings, and then you go to that page. And then that's where all of your information about your string is going to be. Essentially, we can do the same thing with this dictionary, where we have some thing that we look up to find the value or that content at that page, right? So we're going to create something called new dict. Now, I know I'm just using these names. The reason why is in Python, you know that you have some keywords that you can't use because they're inherently already assigned by the system or the language. So if I add this new underscore in front of the data structure or data type I'm looking at, it just allows me to tell you, hey, this is what I'm using, and this is not a strict data type that can't be used inside of Python, or a keyword argument or a keyword that can't be used inside Python. So I'm just telling you what I'm using. You do not have to name them this way. I'm just doing it because I'm me. So essentially, I can create this dictionary. And the way I do that, instead of the brackets, is these curly braces. And what I'll do is I'll take maybe any value that I want to look up. Let's say, for example, it's a page. And I can have page, and I'll take this page 1. Inside this page 1, I'll say it's an introduction. So introduction. And then I'll add this comma here, and I'll add page 2, and we'll say that this page 2 was operators, and page 3 was maybe something like classes, and then we'll have page 4 just be strings. And yeah, we'll just keep it at 4 for now. So for this dictionary, we have some keyword or some key and some value. So because we have this key, we can look up this key inside this dictionary directly, and we can look at the introduction, right? Now, I don't need to use 1 here. I could just call this page 1 if I wanted to. So you have the option to use different keywords and different values if you like. So let's say, for example, I want to print out introduction. So if I printed this new dictionary and I went like this, I put 0 here, do you think this is going to work the same way that a list does? Let's see. You can see that an error popped up right here for this key error. So it's not like a list where you can just index from the first position and then just print out this introduction. We have a key that's associated with this value. So this can be sorted, unsorted, it doesn't really matter, because we just look for that key value and we get the value that it's equal to. So instead of having 0, we're just going to have it as page 1. And essentially, this key is associated with whatever value is in there. And this can be incredibly useful. So you can see the introduction comes from there. Now, this is essentially one of the best data structures for handling a lot of different complex problems, where it gives you the option to look up value so you can store a value and then look up different things of those values later. And that can be incredibly helpful for a bunch of different reasons. But I'm not going to go into it. It's more of an algorithms thing. But our dictionary can be incredibly useful, especially if you're looking for something like this, right? And essentially, we have a lot of just different options that we can use for data structures and data types within Python. I was about to say algorithms. So for this right here, we have different ways that we can use these things, and we can also go through here, use another for loop. So for a key value in our new dict, we can essentially just have this dot and keys, and we can just print out all of our keys inside of Python, or inside of our dictionary. So it should print out our page 1, 2, 3, and 4 as our keys for this dictionary. We can also do the same thing with a for loop, and then we have a value in our new dictionary, and we can print out our values. And then we just take this and we print out our values. And as you can see here, we can get all the values here. And there's something even nicer within Python that you can do with dictionaries. So we can declare multiple things. So we're going to unpack our dictionary where we have a key and our value. And we're going to unpack this into two different things. So we have our new dict, and we're going to call .items. So this is all the items inside of our new dictionary. So we can essentially print, and we're just going to add this as an F string, our key here as a key, and we can also print out our value as essentially a value inside of Python. So these different data structures allow us to, it gives us options of what we can do within Python. It is very, very useful data structures, and these are going to be our basic one that you're going to use for most things in Python. So we have our strings, we have our lists, and we have our dictionaries. There's other data structures and other data types that we could use and utilize, but these are going to be the most basic ones that you're going to run into. So for now, we're just going to keep it there. I'm going to comment all this code out, and I'm going to push it to the GitHub and give you an option just to look at our expanded data types and data structures. I know I didn't really go over a bunch of new data types specifically, just more data structures that are useful. And essentially, we can have some data types that are just a string type, a list type, and a dictionary type. And we can just use those different types and structures and handle them different ways. There's a bunch of different methods that go along with these, and we're not going to go into it in this video, but we're just going to go over those really basic things. So when you run into these in the future videos, and we're writing some code using these different for loops or doing different things with this information, you're familiar with these basic data structures and the data types that we're going to be using or utilizing for efficiency. There's a lot more technical jargon about why these things work the way they work, some efficiency, some algorithm complexity stuff, but we're not going to go into in this video or into the basic series. That's probably going to go into a later, more advanced series. There's a bunch of different data structures, such as trees and graphs and stacks and queues and a bunch of other stuff that are very, very useful, but we're not going to go into them in this basic series. So thank you for watching. I'll see you next time.